Hello team, today's challenge is Unique Stair Climber, where we are asked, based on the number of stairs, that's this number here, if we could only take one or two steps at a time, how many different unique combinations, or more appropriately permutations, could we take with just that number of stairs? The answer to 4 stairs is 5, right? We could do 4 single steps, a double step and 2 single steps, a single step, a double step, a single step, 2 single steps, a double step, and of course 2 double steps. That would total 5 if you've been paying attention, or if you've been counting along, not if you've been paying attention. Sorry. For 5, it gets a little bit bigger. For 50, it gets way bigger. In fact, the formula for this, if we're looking at it, is right here. Let me paste it in. It looks like this. Okay. I'm not sure why I did capital letters for this. It can be lowercase. At least it is whenever I see it. But this number is in direct relation. It is the previous number plus the number before that. Okay, so the current number is whatever the last number is minus the penultimate or second last number is. Okay. Which, strangely enough, is the Fibonacci sequence. Okay, if you look at that, you start at 0, 1, right? 1 plus 0 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8, and so on, etc. Okay, so what we're doing here with just the 1 or 2 steps is in fact the Fibonacci sequence, and this is something that we've solved many times. Okay, if you've been on this ride with me, I've solved it a couple different ways, but even more than that, I haven't recorded every video there, but there have been a lot of challenges since FreeCodeCamp started doing these daily challenges. So if you have one of those, you can probably use one, and I have one right here from January 2nd. Okay, I recorded a video on that, and we ended with a solution that looks like this, where we didn't do anything for the negatives. We still should, right? But even today, we don't need to worry about that, because how do you do negative steps, right? Like, that's not a thing that's possible. But maybe you're bending the laws of physics, and it is. Either way, there should be a thing there. If it is 1 or less, then return n. In fact, I recently learned I could have actually gone 3 or less, and it still works on this challenge. So if you're on that January 2nd challenge, you can do that. So yeah, 0, 1, 1, 2, 3, right? Anything that is 3 or less, you can just return the number. Things I learned, right? Then we set up some placeholder variables here, right? And these allow us to stay fast. Instead of building the entire array, which I also explored in that video, we just maintain 2 values, the previous number and the current number. Okay, and then we iterate over that based on all of this good stuff, right, to figure out what the value is for that, or what the current number is for that that iteration of the loop. Okay, hopefully that's making sense. If not, please go review that. Okay, but I'm going to copy this out and bring it over, because we can use this directly and play with it. Okay, now that it's in here, we can actually return nth Fib. Why am I doing it that way? I could just copy this. So nth Fibonacci, and we take steps. But okay, with this, we're starting at 0, 1, and we really only care about 1, right? So we care about the one that is over here, right? 0, 1, 1, 2. Okay, because of that, we actually add 2 to this to break free of that number, to get out in front of this first 0, 1, and then yeah, it works. Okay, we can improve on this though. So let's take a look. Let's grab this really fast, and I'm going to bring it down here and call this, what am I calling it? I don't remember. Step permutations. Sounds right. Okay, big complicated word. Spelling it right, permutations. Okay, same thing, we're tossing in n, but we can update this so that we don't have to do the plus, okay? And what that looks like is this line stays the same, but right here, this changes. So this becomes 2 and 3, okay? And we start our I at 3, at which point step permutations, we just grab this right here, commenting that away, return step permutations for steps, and it still works. So if we wanted to, we could take that nth Fibonacci code and make changes to it to get here. And again, we're only ever maintaining two pieces of information, the previous and the current. And that allows us to get the next, right? Which we then funnel into current while pushing current into previous and so on, etc. And it works. And it's great. It's super fast. We don't really need to worry about it. I think it is, if you're into big O notation, it is ON. So it does, the bigger the number, the slower it gets, right? That's just how it works. But in terms of space complexity, I think it's O1, right? So memory, it doesn't use any sort of memory. Very fast, okay? Which is better, right? I mean, that's really, really good. I think if you did recursive stuff like that, the O notation gets exponentially slow, if I remember correctly, unless you're doing memoization, which is honestly a lot of code for what we're trying to do, right? It's a lot of code. This one gets the job done. But what if we already had this nth Fibonacci thing in here and we just wanted to make the adjustment? So we wanted to do this, but maybe not here, right? So we could actually take this code right here, copy it, bring it in, and there's nothing to stop us from reusing this right here. And I really like this idea. So this should still work. Where is it here? What did I do? Nth Fibonacci. Did I comment something out? Oh, you know what? This is N. Sorry, I see it grayed out there. Brilliant. Okay. And I really like this idea of making shell functions that lean on other functions to get the functionality there. That's kind of the whole idea of closures, actually, to make these shell functions that run other code based on information. So if you wanted to hide the n+2, you can do that and you can just rename it and pass in the information. Is it going to be slightly slower? No, probably, but it's not terrible, okay? So we can still do this stuff. And again, it all works. Now, I do want to talk about one last solution here before wrapping up, before doing the thing. And that is, there is a way where we could, I want to be below step permutations. Thank you very much. We could use something called Binet's formula, okay? Binet was a French mathematician, and he worked with the Fibonacci sequence a lot, okay? He figured out that you can actually use the golden ratio to calculate values on the Fibonacci sequence. But there's a catch, okay? And the catch is it fails after around number 70, right? I mean, back then when he created this, he probably wasn't going that high. He was testing things out. And now that we have computers that run super, super fast, we can test this. And the rounding error, okay, there's some rounding, there's some weird math in here with square root and powers and more square roots. And all those little rounding errors will take effect once you get past 70. So if n is greater than 70, you're going to start to see that you are off by a certain amount. What that certain amount is, there's no evenness to it. Okay, it's just how it rounds out. So be careful with that. But it does get the job done, so we can play with this a little bit, right? Because none of our numbers go above that. We can take this and go return this, not n, but steps, okay? And, sorry, steps +2, I believe, +1, see? So with Binet's formula, it kind of, the two ones, right? Well, they're only 1, 1. There's only one 1 inside of here. So you kind of need to add 1 to get past the 0, which is what that was. Getting ahead of myself. But it's clever, okay? And to me, it feels very, very clever. It also suffers from this, whereas our math, rolling up these numbers, is never going to suffer from that because we're always taking the previous 2 numbers and adding them, at least until we get into something that is just super big, right? The maximum number for JavaScript. So that's it. That's kind of how I would do this. Starting way up here, we borrowed some code because we found out that, at least for this challenge, going with 1 or 2 steps at a time, the formula is the Fibonacci sequence. It absolutely is. So 4 steps is 5 permutations. 5 steps is 8 permutations. 6 steps would be 13 permutations. Okay. If we had a test for that, it absolutely would. You can test that in your own time if you want. Okay. Which means that we could in fact steal this code, and that's what we did. We stole it from a past challenge. We had already solved for that, and we held that information and looped through until we got the Fibonacci number based on the steps. Maybe n should have stayed as steps in most of these examples, but based on the number of steps we had to cross, we returned whatever that current number was. Now for this, because we started at 0, 1, we did need to add a couple, right? And then we went and adjusted that in here, making some small changes to these previous and current and the I in order to make sure that we didn't have to do that. But really, if we already have access to this function, then why not just make this this step permutations function a shell, right? And that's what we did here. So we took that original code down here and we put it inside of that shell. And then we talked a little bit about Benet's formula, which I just copy and pasted in there, right? It is some heavy-handed math, but there are whole documents on this, whole Wikipedia articles just on this formula, okay? It is beyond me, but I love the elegance of it. The problem being that it doesn't work over numbers greater than 70. At least in my testing, you might find that it starts to fluctuate earlier than that based on the performance of your browser, right? It is very browser dependent, so be aware. And yeah, that's it for today. Did you like one of these solutions? Which one did you like best? Did you find a different way, right? Of course, there are other ways. We could create the entire array and then just pull off the last thing, right, to get there and get it done, right? Let me know all that stuff. If you liked it, if you hated it, if you found a different way, put it all in my comments. I want to read those. Otherwise, today, this has been Unique Stair Climber, which happily lines up with the Fibonacci sequence. And I will see you tomorrow.